Hello, students. We're going to work on a second day of a look at increasing and decreasing functions and concentrate on sketching a graph. And I've got 4 examples for us to look at. You've done this before, but now you have a little bit more information about how you get these critical numbers and what their interpretations will be. So we're going to look at on this front side where we know the original function, and from that being able to sketch a derivative. So when you know the original function, you want to look at where that original function is increasing or decreasing. So as I start looking on the left here, I notice that this function is starting high and moving low. So I would call that decreasing. And notice that this is really the first thing that I am filling in is what I notice about my graph. I notice that my graph is decreasing. And I can look at where that's occurring. So since it's on the left of the graph, it's occurring when x is at negative infinity, and it stops the decrease. Now, I am going to have to estimate just a little bit. Based on the scale, I'm going to estimate that this happens at -1. And again, it is a little bit of an estimate. And then to get an accurate graph, I'll look and see what's happening at x equals -1. And I can see that I have a relative minimum. So I have a relative minimum, and it looks like the ordered pair at this point is -1, -4. All right, and then I would go to the next section. I see that the graph is increasing. So I'm going to go from x equals -1 to my next place that it would stop increasing. So again, I looked at that first. It was increasing. And that stops when x is 0. So then I'll look at x equals 0, and I have a relative maximum at this point. And that happens at 0, 0. That one's pretty clear to tell. And then I see the function decreasing. So decreasing again. And where this occurs would be from 0 to, again, having to estimate. I'm going to say with symmetry that might be at 1. And then at x equals 1, I have a relative min. And again, with symmetry, I'll say that that's at 1 and -4. And then finally, the graph is increasing. I see that that's increasing for the rest of the time. And so I'll go from 1 to infinity. So notice that I filled in my characteristic of the graph as well as my intervals first. And then the last thing that I'll do is look at what are the implications for the sign of the derivative. So I know that if I have a decreasing function, then my derivative is negative. And remember that that means that we will be drawing below the x-axis. This is below the x. And then at x equals -1, since we had a relative min, we know that we have a critical number. And so we'll have 0. And that means that on our derivative, we actually have an x and a y value of -1, 0 that we'll be able to graph. And then my original graph was increasing. That means that my derivative is positive, or in other words, it's going to be located above the x-axis, so above the x. At x equals 0, I have a relative max. That means that my derivative is 0. It would have been a critical number. And so I have an x and a y value of 0, 0. And then my graph was decreasing from 0 to 1. So that means my derivative is negative. I'll be back below, or the derivative will be back below the x-axis. And then at x equals 1, there was a relative min. So that's a critical number. And so you have an x value of 1 and a y value of 0 for your derivative. And finally, on that last interval from 1 to infinity, the graph was increasing. So that means your derivative is positive, and the graph will be located above the x-axis. So I'm going to be graphing f prime. So I'm going to be using this middle column to do that. And I asked you to graph it on the same grid. To do that, we'll be plotting these points that we know. So we know -1, 0. One thing I want you to notice is that curve occurs at the same x value as the relative min. So you want to line that up. -1, 0 should happen directly above the relative minimum. And then for the next point that we know, which is 0, 0, that actually is the relative maximum. It occurs right on the 0, 0. And then your final one that you know is 1, 0, again occurring right above the relative minimum. So those 3 points are points that we can plot for the derivative. And now we're going to sketch the rest of the derivative based on the location of it being either above or below the x-axis. So the derivative from -infinity to -1 is supposed to be below the x-axis. So I'll start low and I'll hit my x-axis, and then I'm supposed to go above the x-axis, but I have to be prepared to hit 0, 0 above the x-axis. So I'm not really sure how far above, but somewhat above. I'm going to erase that part and try again. We'll be learning some other pieces to this, but for right now, I'm actually going to start this first part over. And sometimes you just have to do that. I want it to look continuous. That's a little bit better. And then the next part that I will look at is that I have to, after hitting 0, 0, go below the x-axis again, but being prepared to hit 1, 0. So I'm going below the x-axis. I don't know how far below, but I know I have to be prepared to go back up. I should see a little bit of symmetry in this graph just based on what the original function had. And then finally, I'm going above the x-axis once I hit 1, 0. So above the x, Maybe not quite straight up, but certainly looking, try one more time, certainly making it look continuous. And I'm going to let that be the case. So now we have a graph of the derivative on the same grid as we have the original graph, and that would be f prime. So notice that I did not give you a function, and I really don't want you to think of it in terms of what was that original function. I'd rather you analyze what is going on with f and then use that to draw a graph of its derivative. I'm going to clear this ink and we'll look at your second one, which is a little more challenging. So on this graph, we actually have a monotonic increasing graph. This graph starts low and it moves high without ever turning down. So as I look at what's going on, I see that I have an increasing graph. Now, I do see a little bit of an unusual situation. And that unusual situation would be, oh, excuse me here, I got on the wrong page. Let's try this again. Okay, I'll try this again. So we're increasing in this section. See a little bit of an unusual situation right here on the y-axis. In fact, it looks vertical. And so I'm actually going to write that. That's a characteristic that I am noticing about the function. And then it continues to increase. So as I think about my intervals, I'm going from negative infinity to the x-axis, or excuse me, the y-axis of 0. And then at 0, I see this vertical looking part of the graph. And then from 0 to infinity, I see the rest of my interval. So if f is increasing, then f prime must be positive, which means that it needs to be located when we graph it above the x-axis. And so that occurs in both of these situations where we see that the original function is increasing. So we're going to be graphing our derivative above the x-axis, but we've got this little spot on the y-axis where we see a vertical piece. And so that means that the derivative would be for a vertical tangent, which means that we have an undefined slope. And if we're going to have an undefined area of the graph at 0, then that means that we're going to have a vertical asymptote. So when I get ready to draw the graph of the derivative, my y-axis is going to serve as a vertical asymptote. And I need to draw a graph that stays completely above the x, that reaches to a vertical asymptote, and that starts pretty flat, and then as it becomes vertical, becomes very steep. So my numbers are low, and then they quickly go high. And then this one is steep at the beginning, but flattens out. So my slope numbers are high, but finished low. So notice that I stayed above the x-axis and I reached that undefined vertical asymptote. So those are a couple of graphs. And again, this is a graph of f prime. Those are a couple of graphs where you know the original function and you have to graph the derivative. I'm going to move to the back and we'll do the last two. So on this, you have to switch your thinking a little bit. Here you know the derivative, and we have to find the original function. So this time, instead of looking for what's going on in terms of decreasing and increasing, you need to be focusing on where is the graph positive or above the x-axis, and where is it negative or below the x-axis. So until this graph reaches 0, it's above. So from negative infinity to 0, our graph is positive or above the x. And then from 0 until 1, so from 0 to 1, our graph, so I'm going to put x equals 0. And then from 0 to 1, our graph is below the x-axis. So the sign of f prime is negative. And I might point out that at 0, our graph has a value of 0. And at 1, our graph also has a value of 0. And then finally, from 1 on to infinity, our graph is above the x-axis, so positive above the x. And so notice that I filled in the derivative column along with your intervals this time. So now you're making a conclusion about the characteristic of f. So if f prime is positive, then f is increasing. I'm just going to abbreviate this time. If f prime is negative, then f is decreasing. And remember, we talked about that if your graph changes from increasing to decreasing, then you have a relative maximum. Now, on that relative maximum, all you know is your x value. We don't know your y value, but we do know that it happens when x is 0. And then in my last interval, f prime is above, so f is increasing. And so we have a graph that changes from decreasing to increasing. That means we have a relative min. And again, we know that it happens when x is 1, but we do not know the y value. So as you draw the original function, you have a little bit less knowledge. You do know that you need to have a maximum at x equals 0 and a minimum at x equals 1, but you don't really know where this graph is to be drawn. So we can start low and shoot toward the y-axis, because somewhere there on the y-axis we'll have this relative maximum. Then we'll need to have the graph start decreasing, and we need to keep in mind that it's going to be decreasing until, so there's the increase, stopping at the y-axis, and then it needs to start decreasing until it hits 1, And, that might happen at the x-axis, but we don't know that for sure. So it could happen above or below that x-axis. We don't know, but we know that it happens at 1, that we have a relative min, and then the graph increases again. Now, what should be happening is that your x-intercepts of f prime should be lined up with the maximum, and then here's the x-intercept and the minimum of your original function. So take a look at how those things line up. The x-intercept of the derivative is where you have a maximum for the original function for f, and the x-intercept again of the derivative where you have a minimum value. So there's a graph of the original function given the derivative. And then finally, we'll do our last graph. And this one is oddly shaped. You have a graph that looks like it goes below the x-axis right in here. And then definitely we have an asymptote that is happening as we go here and here, and then looks like staying above the x-axis for the rest of it. So again, we're looking at f prime. So until we get to -1 right here, so from negative infinity to -1, that graph is below the x-axis. Just barely, but it is below. And then at x equals -1, we have an x-intercept. So your y is a 0 for the f prime. And then from -1 to 0, so when x is 0, your derivative is above the x-axis. It's a positive sign. At x equals 0, we actually have undefined. So x equals 0, your graph is undefined. And then finally, we go from 0 on to infinity, and notice that your graph stays above the x-axis. So you have 2 aboves in a row. And so if we take a look at the characteristics of f based on what we've discovered, since from negative infinity to -1, the derivative is negative, that means the f will be decreasing. Going to our next interval from -1 to 0 with f being above the x-axis, then the derivative or the original function is increasing. So now we can think about, since we're going from decreasing to increasing, we have a relative min, and we know the x value. We don't know the y, but we know that it occurs when x is -1. We don't know the y value. And then from 0 to infinity, we know that our graph is increasing because our derivative was positive. And so this undefined, we know that we could either have either a vertical asymptote going on, or that the graph just goes vertical there. So either having a vertical asymptote or the graph going vertical there. So there are a few unusual ways that this graph could look, but one thing that has to happen is whoops, I scooted that down just a little bit. One thing that has to happen is that from negative infinity to -1, we need to have a graph that is decreasing. So starting high and moving low. And then at -1, it needs to have a relative minimum. And then after that, we need to be increasing. So the graph has to increase. But as it approaches 0, that graph needs to go vertical. So one way that that could be drawn is just to have it kind of go vertical here and then start increasing. So maybe it's a little smoother than that. I might try that again. So we're approaching here. We're going to go vertical and then increasing again. So it's somewhat of a unusual graph. That might be what it looks like. There are other interpretations of it. The big thing, I think, if you drew a vertical asymptote with it, you could also make an argument for it to look like this. So having that minimum at -1, doing something like this, and then something like this, having a vertical asymptote, but it is increasing. Notice that this graph, your F, and so both of these are graphs of F, just possibilities that really fit this description. So you'll be in this assignment asked to do some sketches of either the original function or the derivative, and I want you to analyze the graph, use your tables as a way to organize your information. Continue to ask good questions as you are looking through your homework. This is your last assignment before we do a review and then your next quiz.